No, I don't want it to record screen 2 because that screen 2 is my over here that has nothing on it. It'd be a boring video. Yeah, it is. It's cut off again. Everything's cut off. Okay. Anyway, here we go. Day 2 of section 7.4, Michaela. So we're going to change gears just slightly from what we did yesterday, but it's gonna circle back to the same idea of what we did yesterday. Okay, so hang with me. The function y equals e to the x. Remember, we dealt with e on the first day of this chapter, right? You had that e pert or a pert equation that you guys were working with on that yellow paper, had the e on it. You guys were like, wait, e is a number, and it kind of freaked you out a little bit. All right, so we're going to deal with that. So e always opens up an exponent, correct? If you type it in your calculator, it automatically pops up to an exponent. It has an inverse called the natural logarithmic function. On your calculators, where did the e show up? Where, like button-wise, where did it show up? Okay, it was over on the side. ln, right? It was the second part for ln. Now on your calculators, like where x squared is, what's the second part for x squared? Radical, square root of x. They're opposites of each other, right? That's how it shows up on buttons. Same thing here. The e is like the opposite or undoing the natural log. That's what that ln stands for. Now, why it's not nl for natural log, I don't know. Everything comes from, math came from a different language, from Latin and whatnot. Everything's a little backwards in our language. So if you ever see log with a base of e, right, if there's no base, we assume it's a 10. But if you see log with the base e, that is what we call natural log. So anytime you see that, log base e, instead of, figuring out in your calculator how to type all that stuff in there, you can use the natural log. That's what that's referring to. Okay, so it's a different button on your calculator. All right, so how are log of 3 and natural log of 3 different? Well, grab your calculator. Let's at least start there. So what did you get for log of 3? Because that's one I can type in my calculator. 0.47. And it keeps going. All right. How about natural log of 3? So hit the ln button and then hit 3. 1.0986. Da, da, da. All right. So obviously their values are different. So let's ask the question, what are they really asking you? So what's the base here? 10. So this is asking you 10 to what power equals 3? That's what that asked you. What is this asking you? This is really saying log base e of 3. So that's asking you e to what power equals 3. I want to make sure you're aware of the difference. You can't use them interchangeably, okay? So if you see the ln, the natural logs, that stands for, that means it's a log with a base of e. So it's asking e to what power is going to give you that number. Do you guys remember what e is? It's like, yeah, it's like 2 point something, 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 something. Right? Type in e to the first power if you want to know. It'll tell you what it is. Right? But that's 2 point something. It's an ugly decimal that goes on and on forever, kind of like pi, right? It just keeps going forever. All right, so I want to make sure we're clear on the difference. So you cannot use them interchangeably, okay? One or the other. Okay, so let's get a little practice just with the calculator buttons. Let's type in natural log of 2. You guys want to see something cool? You're impressed, right? Are you impressed? It's a little harder to see, but so 0.6931472, blah, 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 blah. You're doing something wrong. All right, guys, try the next one up there. Natural log of 0.3. This is ridiculous, but here. Nope, just natural log.
See, that's what I'm doing wrong.
Yeah, it is. You're typing e to some power. It's asking you e to what power equals 2. That's what it's asking you. But we can just hit the natural log button. All right, what about natural log of 0.3? Negative 1.20397, blah, 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 blah. Natural log of negative 1? Why? But why? Error. I want to make sure we know why, though. What is it asking then? If it says natural log of negative 1, that means it's log base e of negative 1. So it's asking you e to what power equals negative 1. What value is e? It's 2 point something, right? Can you take a positive number and raise it to an exponent and make your answer negative? No, you can't. You can't do it. It's not possible. So that's why there's an error there. All right, how about natural log of 1 plus radical 2? Make sure you're okay on buttons on the calculator there. 0.8813736, blah, 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 blah. Blah, 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 blah. All right, questions on buttons on the calculator. That's half our issue sometimes, right? All right, so here we go, guys. Students in an Algebra 2 class, were given an exam and then retested each month with an equivalent exam. Sounds like a lot of testing. You guys get tested to death enough. I'm not going to do that. The average scores for the class are given by the human memory model. Some people have way too much time on their hands. This is the human memory model. So you have function where 86 minus 7 times the natural log of t plus 1, where t is between 0 and 12, because we're talking about months, right? There's 0 to 12 months. So here's a real-world example where they've actually used the natural log that works into its calculations. Again, people have too much time on their hands. Okay, so there's that function again, so we can use it. What was the average score on the original exam? How do you figure it out? On the original exam, what would the number of months be? T stands for 0 to 12. So it would be 0. So, yep. So the original, the initial, right, like ground zero, breaking in, like that's going to be a 0. So let's go ahead and figure that out. Let's 86 minus 7 times the natural log of 0 plus 1. Obviously, you wouldn't have to put the 0 in there. All right, so let's go ahead. Let's practice typing that in, make sure we're okay. 86 minus 7 times natural log of 1. And I got 86. All right, so what was the average score after 3 months? So what's my t value? 3. So we're going to do 86 minus 7 times the natural log of 3 plus 1. Well, you think about test scores. Where do we really kind of want test scores to? Don't I round? Aren't I nice to you guys? So 76.3. Talking about percentages here. So is the memory model, wait a minute. Why is it getting worse? Oh, it's testing your memory. What happens with your memory? It goes down. Now, obviously, if they studied every time before they took it, then what would happen? They'd go up. But this is like saying, hey, I taught you something here in the beginning, we take the test right away. How about if I re-gave you your chapter 2 test now? Now, maybe in math, because everything is built upon each other. Well, let's think about like maybe history class. Go back and retake the first test you ever took in history. Do you know what I mean? Like, that's something that like doesn't like keep building. Like math keeps building. But if you stop studying something, what happens to your memories? They start to fade, right? They start to not remember as much. Yeah. But math is something that builds. Like we keep using it. We haven't went over factoring in how long? If I gave you a problem to factor right now, could you? Hmm. You could. Because again, it's built in. I taught that to you a long time ago, way back at the beginning of the semester. But you've used it so much in other things that it just is now part of your, you've remembered it, you've learned it. There's a difference in remembering and learning. Right? Do you guys agree to that? There's a difference in remembering and learning. All right, so what was the average score after 12 months? 68? Yeah, 68.04 would just be like 68, 68.0%. So what happens? What is this telling you? The memory model. The further away you get from something, the worse you're going to do. Now, if you study and you keep working on it for that whole year, what should happen to the test score? It should go up. Yeah. All right. So I told you we're doing something a little different, introducing the natural log stuff, but it's going to circle back to what we did yesterday. What is each expression written as a single natural logarithm? So those properties apply to natural logs as well. So the number in front becomes an exponent. So if it wants it as a single log, I'm going to only write natural log once, same way we did with regular logs, this is going to become 15 squared. What's minus? Divide by 75. Is it possible I can clean that up some? Yeah, what's 15 squared? 225. So natural log of 225 over 75. Does that simplify? That is 3. Natural log of 3. Is that a nice, pretty answer? Natural log of 3? If you type it in your calculator, can I just give me one number for an answer or no? No, that's not pretty. So we'll go ahead and leave it here. Leaving your answer natural log of 3 is equivalent to you leaving something as like radical 7. Because radical 7 stands for a number, right? It actually has a value to it. But why don't we write the actual value out? It's ugly. But even if it's ugly, I mean, there's people in this classroom that are ugly, but we still see them every day. Hey, you guys are paying attention, just making sure. But why do we leave it like radical 7 as opposed to the ugly decimal expansion? Why do I make you write 1/3 instead of its decimal? It's 0.3333333. Can he keep going all day long? Because does that decimal ever stop? Never stops. Same thing with radical 7. The decimal never stops. Natural log of 3, the decimal never stops. So we don't write it because otherwise I'd have to round it off and then it's not the same value. So that's why we leave it natural log of 3 and don't give me the decimal expansion because it's not exact. All right, how about natural log of 7 plus 2 natural log of 5? So natural log of 7 times 5 squared. Because I'm trying to write it as a single. Okay, just making sure we're okay. Good, so this is natural log of 7 times 25. So then I would stop there. Very nice. But you see the same properties that we practiced and learned yesterday with logs, they apply to natural logs as well. All right, same idea. Still doing it as a single log. Let me give you guys a minute. Try both of these for me. See if you can put them back together. All right, guys. Let's try the first one here. So again, what's the number in front mean? It's an exponent. And we're writing as a single natural log. So I'm going to write down ln for natural log. Kelsey, Michaela. So this is going to come up as x cubed. The subtraction means divide. This 2 comes back. Well, where does it apply to? Everything. So what's 2 squared? And then x squared. So there would be the first part. And then I need to look, can I simplify it? Yeah. Natural log. X cubed over x squared is just x left on top and the 4 is still on the bottom. Yeah, a lot of people put this 2 on the x and they forget to put it on the 2. Yeah, since it's in front of that whole piece, it applies to everything. All right, and then the next one, again, we're going to have 1 natural log. This comes up as x cubed plus, which means multiply. That comes up as y squared plus, which means multiply. And I have 5, which looks awkward if I stick it in the back, so I'm going to put it in the front. So natural log of 5x cubed y squared. If you had x cubed y squared 5, it's technically not wrong. It just looks really weird. Would you write 5x or x5? Yeah. But Caleb, would you write x5 or would you write 5x? Right? x5 sounds funny. That's the only reason I put it in the front. It's because it just looks weird at the end. It's not wrong if you put it at the end, but I mean, look at that. I mean, that looks weird. This isn't wrong. It just looks weird. We're used to seeing the number in front, so I just put it in front. Good. Questions? Are we doing okay? Making more sense today after I've drilled and practiced you to death today? All right. So we're going to switch gears one last time. Your calculator can do every single log that I ask you to, no matter what the base is. The graphing calculator has the capability in it to change the base. I'm not telling you where that button is, but if you find it, good for you. But I'm not showing you where it is. But anyway, I'm going to show you how you can do it on any calculator, even those scientific ones. Even on your phone, you can do it, because your phone has the log button on it. So you can use the calculator to find values of logarithms with base 10 that does it naturally. But evaluating other logs is not quite as simple, but we can still do it. For example, to find log base 9 of 243. Right now, your regular calculator can't do it. So we have what's called the change of base formula. We can change, quote unquote, we can change the base. So, change of base formula. There's a lot of technical math combo stuff up there. We're going to kind of bypass that for a minute. Let me just show you. It's just easier, okay? So what we have, this is your general form, right? So you have log of some base, some number. Normally, your calculator can't do it because it always does base 10. Ramon, Kelsey. So what you can do is do log of x, so log of whatever your number is, and then divide that by log of whatever the base number is. So if we look at an example here, to figure this out on my calculator, I can type in log of 243 divided by log of 9. Use the base as a number out here. What base did I switch this to? 10. I'm switched it to a base that my calculator can do. So when you're typing this in, now be careful with the calculator, because if I hit log of 243, do you notice how it opens a parenthesis after log? You have to close it. Divided by log of 9. It is 2.5. So in other words, 9 to what power equals 243? 2.5. And again, you can check that. Type in 9 to the 2.5 power, and it gives you 243. For the 2.5? We don't, like if I, what is the answer to this? 9 to what power equals this? 2.5. Right, remember loopy swoopy, 9 to this power equals this. Yeah, the change of base formula makes it where your calculator can easily do anything you want it to. So, evaluate using the change of base formula with the common log. So you're switching it so your calculator can do it. Round to 4 decimal places. So let's go ahead and try this. So log base 2 of 12. So what are you typing in the calculator? Good. Right, you type in log 12 divided by log 2. Again, I want to make sure you're understanding what this is doing. What am I asking you to find? What's it asking? Good. It's asking 2 to what power is 12. I want to make sure we're clear on how to use logs, like what their purpose is. So 2 to what power equals 12? Cool, huh? 3.5850. Because how many decimal spots did it want? It wanted how many? 4. It wanted 4 decimal spots. You'd had to type in log of 12, close parenthesis, divided by log of 2. Did you get to work? Okay. If you don't close off that parenthesis, you have a big issue. All right, so log base 3 of 16. I'm asking you 3 to what power equals 16? And what do we get? .5237. Again, you're typing in log of 16 divided by log of 3. And then the last one, log base 5 of 22. Be careful with your rounding. If you wrote the 5 on the end instead of the 6, I'm taking a point off. Hmm? I rounded it correctly. The number after it is 5 or higher, you round up. Well, if I'm rounding to 4 spots, guys, make sure we know this. If you're rounding to 4 spots, so you're looking at that 4th digit, if the number right after it is 5 or higher, it rounds up. The number after it, because I want to go to the 4th spot, because this was a 5, right? What was the next number after? Yes, because it was 1.9205. What was the next one? 7. So you want to go to this spot, the 4th spot. That's where I asked for. So then look at the number after it. If it's 5 or higher, it rounds up. If it's 4 or less, it stays the same. So that's why it's a 6, because the number after it made it round up. We okay, Marcus? You all right? Okay. Questions on anything? We did natural logs, which still practice the same properties we did before. And then we also did change of base formula.